Yo, what's up, guys, and today we're going to be talking about how my Minecraft operating system can store formulas. Specifically, I want to talk about how the computer knows where to place the formula in memory, how the computer will actually store the formula, and how it will access and solve this formula that is stored in memory. First, memory. How does the computer know where to place the formula? All of the memory relating to my data registers is contained inside a single 64-byte chunk of RAM. So if 16 of these bytes are taken up by data registers, I can just start at the 16th byte. The biggest issue here is going to be actually incrementing the memory address, because the formula is not just going to be a single byte. Now, I'll explain this later, but I'm going to fit the formula inside a 4-byte format. So I need to figure out a way to increment every 4 bytes. Now, because 4 is a power of 2, the easiest way to do this is bit shifting. Bit shifting is basically just an operation where you shift a number to the left or to the right. So you add a digit or subtract a digit. Now, if we were to do this with decimal numbers, shifting to the left would multiply by 10 and shifting to the right would divide by 10. So if we're talking about binary, which is a base 2 system, not a base 10 system, shifting to the left multiplies by 2 and shifting to the right divides by 2. So all we have to do to increment by 4 bytes is to bit shift to the left twice. So then we can apply this operation. We can take the specific formula number, so either a 0, 1, 2, or 3. We can then convert it to binary, and then bit shift it to the left 2, and then finally add 16. So we start at the 16th byte, and we can jump every 4 bytes. So now we see how my computer knows where to store the formula in memory. Next, we're going to talk about how my computer formats the formula to be stored into memory. By default, my formula takes up 5 bytes. 2 bytes for the first operand, 1 byte for the operation, and 2 bytes for the second operand. If I were to keep it this way and store it into memory as 5 bytes, it would be much more inconvenient because 5 is not a power of 2. Unlike 2 or 4 or 8, I cannot simply bit shift to increment by that many units. My first thought was, well, both of the operands, both of the two numbers I am operating with, are represented by two numbers, but they actually equal 1 byte. So I took the register, took off the R, and just converted that digit, that hexadecimal digit, into binary. And then for the 2-digit hexadecimal, just standing on its own, I would convert that also into its own binary number. So then I have 2 bytes of operands instead of 4 bytes, and then 1 byte for the operation. So I have 3 bytes. The issue I ran into was that I can't distinguish between which one is a register and which one is the hexadecimal number. So I would need some sort of extra byte to encode this data, to decide, to say which one is a register and which one is a hexadecimal number. Luckily, we have one extra byte. So I use an extra byte. Now I'm only using 2 digits of this byte, and how it works is if the first digit is a 1, that means that the first operand is a hexadecimal number, and if it's a 0, that first operand is a register, and same thing for the second digit. Now that I know where and how to store my formulas, let's talk about accessing it. Hopefully solving the formula should be pretty simple. I have most of the code already there from when I was just normally solving the formula. So it's really just a matter of cleaning up this previous code so I can reuse it. I'll probably finish this up next video, so stay tuned for that, and peace.